everyone, welcome to Organolysis. And in this video I am taking a question, the question which was came in CSIR-NET December 2013 for 4 marks. Okay, now the question was the major product formed in the following reaction sequence is. You have given a substrate like this one and the reagent, that is one is H2O2 and second one is heat. And we all know that in presence of ACPH, that is selenium phenylselenyl group, directly when it reacts with this H2O2, and it generally forms the selenoxide bond. Okay, now this selenoxide is generally unstable and it will try to undergo acid pyrolytic syn elimination, and there is a formation of an alkene. Now see, there is a formation of alkene, we can easily find out, but what about this ring? Now for this you have to know clearly to identify a correct answer to attempt this question also. That is, if this type of ring, that is one SO2 group is inserted by replacing a carbon, and when you have the heat, this compound generally extruded, and this extrusion of this SO2 sulfur dioxide, you get a 4 pi electron ring type system, not ring type, that is open system, 4 pi with 4 pi electron. Okay, now see this, you have the alkene, and here is alkene, that is 2 pi electron, and you get from this system, that is 4 pi electron. So although and you have in your reaction medium, that is heat. So what is the possibility of this reaction? That is 4+2 cyclization. Okay, so there is nothing but nothing to do, that is for this reaction. Okay, so let's start how to solve this question. Now see, you have given a substrate like this, ACPH. Okay, now in presence of H2O2, what will be the product? That is selenoxide bond will form generally, and this is our H2O2. Okay, so this selenium group has lone pair of electron and directly attack on this oxygen center, and this which takes a proton, and this will go back over this oxygen atom. Now we get the selenoxide bond, that is here is SO2. Okay, now see, this is our SO2, bonds go over here, that is a double bond, and here you have the ACPH, this is your OH, there is hydrogen. Okay, now in presence of heat, it generally undergoes the pyrolytic syn elimination, that is pyrolytic syn elimination. Keep in your mind that is syn, okay, always in syn elimination. Okay, now here in this question there is no mention of this, they don't mention the stereochemistry. Okay, so if the question comes with the stereochemistry, so keep in your mind that this elimination always in cis fashion, or you can say syn elimination. Okay, so this is generally syn elimination. Now how the elimination takes place? In this way. Okay, that is how this elimination takes place, and you get an alkene over here. Now see, this SO2, there is a bonded with this center, this is with double bond, and here you can get a alkene like this. Okay, now there is a possibility of cheletropic reaction. Now what is cheletropic reaction? That is, cheletropic reaction is nothing but there is extrusion of this SO2, that is sulfur dioxide. And now how to extrude this sulfur dioxide? That is, its bonds go back over here, and these bonds go over here, and this will go back over here. Now see, there is a formation of these two double bond, there is a double bond over here and over here, and this SO2 will leave from the system, that is minus SO2 will leave from the system, and ultimately the product that you get here is like this. Okay, so this is how you can get this 4 pi electron system, and the final, that is this rest part that you have, it is one CH2, and here is your double bond, and here is this alkene. Now you can easily predict that what will be the reaction and what will be the all things. Okay, so this is our cheletropic reaction. Okay, so this is your cheletropic reaction, that is how this SO2 will extrude from the system, and you get this 4 pi electron, and this here is a 2 pi electron. Now see, what will be the possibility of this reaction? That is, you have the reaction medium, your heat is present on your reaction medium. So in presence of heat, that is 4+2 cycloaddition reaction, okay, in presence of heat. Now what will be our product? Now our product is look like these bonds tap over here, these bonds go here, over here, okay. So there is a formation of this. Now there is a bond over here, so this ring will be 5-membered, and there is a formation of 6-membered, okay. So there is a bridge bicyclo compound like with a 6-membered ring and with a 5-membered ring, okay. So now see, there is a, now the question arises, how now this double bond, now here is a formation of double bond. Now the position of this double bond is important. Now see, there is a bond formation, that is this one, and this double bond goes over here, so that is in this position we are getting the double bond, okay. And here you have the double bond O, okay. Now the question may be difficult, or in some cases if you have given the junction positions are different, okay. So the junctions always in C's, okay. So here the question is quite easier, that is the junction is you can easily predict the answer from here. That is, there is a two possibility of this reaction. There is a two product that we have given by the 4+2 cycloaddition, but in this 4+2 cycloaddition the junctions remains same, that is both in case that is C's, okay. So either this is in sense that is these two hydrogens either is in backside or either is in above the side, okay. So you can say it easily. But if the question arises that is this hydrogen is in upside and this is in downside, that is the trans junction, okay. So that is why you can easily answer it. Just you don't need to worry about this, either it is C junction or trans junction. So that is why the question is too much easier for this type of question, okay. Now see, from this type of SO2 type of compound that we all know, this is extruded from the system and you cannot get this product. So option A you can easily eliminate from the system. And there is also possibility of this there is no possibility of the formation of this benzene type of ring, so you can easily eliminate these options also. So you have left this option, this either option C or either option D, okay. So from this type of from your product, that is this is your desired product, okay. So this is our desired product, okay, by the using 4+2 cycloaddition, and you get the ultimate product, that is the double bond over here, okay. So in option D is our correct option, so this is our also wrong option, okay. Now see how the question, how the important question was, how the easy question also. You have to know that for this you have to know to solve this question, that is this SO2 type of compound generally extruded, and this is the selenium for this heat. If you have heat, and you have to know there is a formation of this 4 pi electron, and for this 4+2 cycloaddition reaction you have the 4 pi electron, but you have to generate this 2 pi electron system by using H2O2 in case of this selenium pH, okay. So that's it for this video, and I hope this video is very much helpful for you. And if you find this video useful, share it with your friends, and please like this video, and it motivates me to make more good videos, okay. And that's it, and thank you so much for watching.